So you have heard of the word memory leaks maybe 1,000 times, and like you sort of maybe have a good idea of what it means, but we have been also discussing about it in the past few videos. Here my attempt would be to, let's say, build a rough intuition about how would you sort of generalize, or how will you sort of see memory leaks from an intuitive perspective, and how would you sort of bring it to your day-to-day life and the things that you see on a day-to-day basis, right? So how will you build an intuition to understand memory leaks in general? And in the next video we'll move on to take this intuition and build an implementation on top of it, like we have been doing for every other use case, right? So this video is mostly about understanding memory leaks and building the intuition, mostly like how do you sort of understand it intuitively that this is something that could be causing a memory leak. So yeah, let's take an example first. So let's say we have this situation, right? Let's say we have this is the initial part, so just forget about all this. So let's say we have a glass of water, and the glass of water is filled with, of course, water. Then we have a few glasses of different sizes, let's say. So what we do is this is the starting phase. We redistribute the water among all the glasses. So we fill all the glasses and we let it be there for some time, let's say for t1 duration or something. And then we again then we again collect the water from every glass and put it in the same initial glass that we had initially, right? So assuming that none of these glass have any leakage or anything as such, what we should expect is ideally this starting state should be the same as the ending state. That's a basic expectation for you to not have a leakage or anything as such in this case, right? So let's take the case where maybe there is a leakage in some glass, right? So let's say this glass has some leakage, and let's assume the water is memory. So some of the water will leak to the bottom of it. Let's say it's here, and when you recollect it, you will have less water than you had before. So this is a consequence of leakage in water in our use case, and if you consider water to be memory, we will soon see how this will sort of correlate to memory leaks in general, right? So yeah, that's sort of the basic intuition that you need to keep in mind to understand memory leaks. You start with a state with some certain amount of resources, and that state would sort of correlate to, let's say, building a UI. So it's that starting state would sort of correlate to the starting, like how the UI looks like in general. Then you perform some activities in the UI, and after that, when like you do some activities which again takes you back to the starting state, that should consume the same amount of resources that it did initially. If it's not intentional to have it like hold some state or use it anywhere else, right? So let's take an example of a to-do app, right? So let's say in an example of to-do app, what you do is you have a button. Let's build it out here for the sake of simplicity. Let's build it out here. Let's say this is the screen, and then you have a button here to maybe so let's say we have build a to-do list app, and we have this input field here. We take the input field, we have a button to add some to-do item there, and let's say this is the starting state. So this will sort of correlate to this one. Then what you do is you enter items in your list. You keep on entering them, and let's say we have a list here, right? So this is sort of the intermediate state that you have. So let's put it here. So you have this to-do list application, you have this intermediate state. So this is sort of based on your interaction with the UI, you sort of create a intermediate state where you have these kind of thing, right? So you redistributed the water among, or the resources among whatever you had here, and each of them also has a delete button in the end. So you can sort of delete it and like it will disappear from the screen, right? So what's our expectation with no memory leakage in this situation should be, if we delete this, that's like you are putting the water back in the initial jar that you had, right? So eventually when you delete all of it, when you are done with your tasks, we should be back with whatever we started off initially if there is no memory leaks. if there is memory leak, you will sort of have a different resource availability, if that's what you call it. So basically, let's say you start at maybe some memory of 5, you do the intermediate states, and then you again go back to the initial state. You would like come down to, let's say, memory of maybe 8 or 9. So it's 3 or 4 above than what we had, which is accounted for this part, right? So we'll see it in example also, but just to sort of connect both the situations, I wanted to demonstrate this. So that's what is mostly memory leak. So you end up allocating your memory to something that you are not using anymore, but you are not aware of it. So that's why it's a leakage, and we should keep it as less as possible, because of course it consumes resource and it sort of makes it unusable until you realize it, like it's being used anywhere. So in the next video, we'll sort of understand how to identify memory leaks, how would you sort of like see what's going wrong, or if something is going wrong, and how to resolve those aspects using some of the tricks that we discussed in the last video, right? We discussed some tricks to help the garbage collector handle memory very efficiently. So we'll sort of use those kind of thing to maybe some tricks from there to sort of trigger the problem. First of all, we'll simulate a problem. We will simulate this implementation that we discussed, and then we will solve it using those things that we mentioned in last video, right? Okay, yeah, I think that should be it for this video. Do share it with your friends if you liked it, and drop a comment for feedbacks. Would appreciate it. Yeah, bye.